Hello, Honors Algebra 2 students. This is Coach Apollo, and this is video for lesson 6.4, Polynomial Functions and Their Graphs. First up, what I want you to do is think back to one of our last lessons and think back to long division. And knowing how simple the lesson on long division was, but imagine trying to do long division, but you couldn't multiply. So you have all your skills and you know everything you need to know about long division, but you don't have the basic skills of multiplication, so you can't do it. I bring that scenario up because that's what this lesson is about. This is the basic skills, and you really need to pay attention and make sure that you understand all of these concepts because they are going to be very important, obviously for the rest of Unit 6, but going into Unit 7, they're going to be very important. And so one of my suggestions is going to be that after these notes are done and before you start the homework, go back to these notes and go back and highlight the vocabulary words and their meanings and make sure that you know these rules and the vocabulary backwards and forwards. All right, so let's go ahead and get started. So this is the equation that we are going to be dealing with here for the first part of the notes. And that equation is 4x cubed plus 5x squared minus 2x plus 1. Now, this is an example of a polynomial. It has 4 terms. This is term 1, 2, 3, and 4. And yes, the 1 is a term, even though it doesn't have a variable. Now, we don't have a name for a 4-term polynomial, but we do have a name for a 1-term, a 2-term, and a 3-term. And you are responsible to know those. So a 1-term polynomial is called a monomial. A 2-term polynomial is called a binomial. And a 3-term polynomial is called a trinomial. Now, these names refer to an equation, not its graph, but an equation. All right, in this equation, we had 4 numbers. 3 of them, 4, 5, and negative 2, are attached by multiplication to a variable. So those are called coefficients. The 1 is not attached to a variable, so we just call that a constant. The number 4 has a more specific name. It's not just a coefficient, but because it's attached to the exponent with the largest, the variable with the largest exponent, it is called the leading coefficient. And it's called the leading coefficient because it will always be the first coefficient in the polynomial. Now, next thing I want you to notice is that right here, the exponent are in order, 3, 2, then there's a 1 in there, but we don't ever write exponents with the 1, and then there's a none. But that 3, 2, 1 order is standard form, and it is called descending order. So we're writing the exponents in descending order. Now let's talk a little bit more about those exponents. We've got a 3, a 2, and again, like I said earlier, we have a 1 exponent right there, right up here on that x. Because the 3 is the highest exponent in our problem, then we know that this polynomial has what we call a degree of 3. Now, the degree is important because it's going to be able to be used for 2 different things. First, it's important because it's going to tell us how many turns, otherwise also known as curves, the polynomial's graph will make. And how you'll determine that is you'll take the degree and you'll subtract 1. And the degree subtract 1 is the number of turns a graph will have. Okay, and so for instance, in this equation, or in this graph right here, this has one turn. Here's that turn right there, turning around. And the reason that it has one is because the equation here, the leading coefficient, or excuse me, the degree is 2. So this might be the equation y equals, say, 3x squared minus 4. So the degree is 2, and 2 minus 1 is 1. So that's why we have one turn down here at the bottom. All right. Now, the degree can be used for something else. It also tells us how many solutions, or otherwise known as zeros, are possible for this polynomial, but not guaranteed. So a quadratic equation that has an exponent of 2 as its largest exponent could have 2 solutions. It could have one solution, and it also could have no solutions. Okay, so remember, this same graph right here, this quadratic, if this was the xy axis, then it would have 2 solutions, that one and that one. Now, if the y-axis, or excuse me, the x-axis was right there, now it only has one solution right there. And lastly, if the y-axis is down, or excuse me, again, the x-axis is down here and the y-axis is here, then we have no solutions because this graph doesn't cross the x-axis at all. So again, the degree does not guarantee the number of solutions. It just tells you how many you might have. Now, the graphs of polynomials are called continuous. They're called continuous because if you look back here on the back, okay, they're called continuous because if I put my pencil down at one end of a graph without lifting the pencil, I can get on the entire graph. Same thing over here. I start up here, go down, go up, go back down, and again, without lifting my pencil, I never go off the graph. So that's why it's called continuous. Now, we are moving towards what we call discontinuous or not continuous graphs. And so here's an example of a graph we're going to be looking at in Unit 7. Now, notice these blue lines right here. Okay, these blue lines right here are called asymptotes. Okay, and they are lines that the graph cannot cross, which is why you see this graph getting closer and closer and closer to -2, but never touching it. Same thing over here. This graph is getting closer and closer and closer to the 3, but never touching it. Okay, so we'll talk about those later in the next unit. All right, so now let's talk, let's go back here. What I want you to do is I want you to look at this graph. Okay, now this graph right here, on the right-hand side, we're going up, and on the left-hand side, we're going down. All right, over here, on the left-hand side, we're going down, and on the right-hand side, we're going down. This graph, on the left-hand side, we're going up, and on the right-hand side, we're going down. And so if you look at all these graphs, it's one or the other. Either both of them are going in the same direction, or the ends of it are going in opposite directions. So there's a pattern for that. There's a pattern for knowing when is the graph going to go in opposite directions and when is it going to go in the same direction. Now, not only is there a pattern for that, but also if you look here, here's 2 going in the same direction, and also here's another 2 going in the same direction. But up here, they're going down, and over here, they're going up. Now, in this graph, they're going in opposite directions, but the right side's going up and the left side's going down. Over here, the left side's going up and the right side's going down. So we've got 2 patterns going there. And that's what the bottom part of page 1's notes are for. All right, so let's look and see what it says. This says that if the leading coefficient, all right, so remember that would be the 4, okay, that would be the 4 right here, and the degree, that would be the 3 right there, okay? So if the leading coefficient is positive and the degree is odd, then the graph will go down on the left and up on the right. If the leading coefficient is negative, but the degree is still an odd number, then the graph will go up on the left and down on the right. All right. If the leading coefficient is positive, but now we're going to change the degree to an even number, like 2, 4, or 6, then the graph will go up on the left and up on the right. If the leading coefficient is negative, but the degree is still even, then the graph will go down on the left and down on the right. Okay, this behavior, either the ends being the same direction or opposite direction, this is called end behavior. What is happening on the ends of the graph? So this is end behavior. Now don't get me wrong, these graphs never actually end, but they do have tendencies towards the end of a graph. Okay, so again, end behavior. So let's go talk about these graphs. Okay, so this graph right here is y is equal to x. This is a linear graph. You are responsible to know that any graph that has a degree of 1, which this equation has, is called linear. Now, let's go ahead and add another piece of information. This graph has a degree 1. It also has a leading coefficient that is 1, so it's positive. So, what do we know about this graph? We know that the leading coefficient is positive. The end behavior is down on the left, up on the right. How about how many turns does this graph have? Well, you can look right at it and see it has none. Now, how do I know that for sure? Because if I take the degree 1 and I subtract 1, I get 0. How about the degree? Okay, so the degree is 1. I know that two ways. Number one, I know it because there's a 1 on the largest exponent in that equation is a 1. The other way is I can look to say, okay, this graph has no turns, and I know I subtracted 1 from the degree to get 0, so 0 plus 1 is 1 degree. And lastly, how about zeros? Where does this graph cross the x-axis? It has 1, 0 right there at the origin. So it has 1. Now, how many possible zeros does it have? So if we go back to our notes over here, it says that the degree tells us how many solutions or zeros are possible, but are not guaranteed. So this not only has one solution, there was only one possible solution. All right, let's go to number 2. All right, leading coefficient. Okay, before I finish that off, let me give you the equation. Y equals negative x squared plus 6x minus 5. That's the equation for that graph. Okay, this is called quadratic. You need to know that name. Any equation that has 2 as its degree is called a quadratic. In this case, there is a negative 1 in front, And so my leading coefficient is negative. The end behavior is down on the left and down on the right. How many turns does this have? Well, looking right at the graph, I can tell it has 1. Okay, doing the math, it's degree 2 minus 1. 2 minus 1 is 1. Okay, again, what degree is this? This has a degree of 2, right there, 2. How many zeros does it have? All right, well, let's look. It has 1, 2 zeros. And because the degree is 2, it only has 2 possible as well. So it's taken full possibility of zeros. All right, let's go to the third one. Okay. For the rest of these, I'm not going to give you the equation. I'm just going to give you the type of equation. So this is an x to the 3 graph. This is some kind of graph. I don't know what the equation is, but it does have a degree of 3. This is called a cubic. Okay, so we need to know that all graphs that have a degree, or all equations that have a degree 3 will have a cubic graph. All right, leading coefficient. Leading coefficient is, well, let's check. I'm going up on the left, and I'm going up on the left and going down on the right. And I've got an odd degree. Over here, I was going up on the right and down on the left, and that was an odd degree. So this must have the leading coefficient must be the opposite. So my leading coefficient is negative. It's end behavior. I'm going up on the left and down on the right. How many turns does it have? It has 2. And I know that mathematically because I take the degree and subtract 1. Okay, what is the degree? Unless I told you, you have to get it off of the picture. So we're going to think backwards. I've got 1, 2 turns, and I know that the number of turns is the degree minus 1. So if I add 1 to the turns, I get 3 as the degree. Okay, and then how many zeros? Well, I've got 1, 2 zeros. Okay, so I've got 2 real zeros, but because this equation has degree 3, there was 3 possible zeros, but it only has 2. All right, I'm going to write down the equations and the names for each of these. And what I want you to do from here is go to Schoology, back to Schoology, go to the answer key, and fill in the rest. There isn't much information else on here that we haven't already done for these 3 up here. Okay, actually, I'll tell you what, I'm going to do one more with you. I'm going to do one more that doesn't have... Nope, I'm going to do 2 more, and then I'll have you go to the notes. Sorry. Okay, here we go. This is an x to the 4th graph. This is called a quartic, Q-U-A-R-T-I-C, quartic. Over here, this is an x to the 5 graph. This is called a quintic, Q-U-I-N-T-I-C. All right, so I'm going to do these 2 with you, okay? And then I'm going to have you do the last 2 by going to the answer key. Now, when you go to that answer key, make sure you come back and watch this video. Don't just go write the rest of the notes, because then you won't understand, and then you'll be in Mega Lunch asking these questions, and based on your questions, I'll be able to tell you didn't watch the video. So, leading coefficient, I've got, let's see, I'm going up and up. Whereas over here on this even degree, I was going down and down. So if 2 downs was a negative, then 2 ups must have been a positive. Okay, so my leading coefficient is, my leading coefficient is positive, and I'm going up on the left, and I'm going up on the right. All right, turns, I can count them. I see them right away. I've got 3 turns. Degree, well, I told you at the top this was an x to the 4th, but 3 plus 1, right? So 3 turns plus 1 is degree 4. And then zeros, zeros, how many times does this thing cross the x-axis? It crosses 1, 2, 3, 4 times. So this has 4 zeros. And because it has a degree 4, it only had 4 possible. All right, and last one I'm going to do for you, then I will give you the titles of the other 2, but I want you to get the rest of the information off of Schoology. So this one has a leading coefficient. Let's see. I am going down on the left, and I'm going up on the right. Over here on this odd, I was going up on the right and down on the left, same thing. So then this leading coefficient must have been positive. I'm going up, I'm going down on the left, and I'm going up on the right. All right, let's see. Turns, I've got 1, 2, 3, 4. 4 turns. Degree, well, I've got a degree 5 because it says so right there. Or I can take my 4 turns and add 1, and that gives me 5. Okay, and then zeros, let's check them. I have 1, 2, 3 real zeros. But because this was degree 5, I had 5 possible zeros. And what I could have done to get that 5 is this vertex right here, if it had gone further down and come back up, okay, before it hooked back up, so then I would have had 2 more zeros. I would have had 1 more there and 1 more there. Then that would have been 1, 2, 3, 4, 5 zeros. Okay, so I'm going to give you the names of these. This is x to the 6th graph, and this is sextic, and this is a x to the 7th graph, and this is called a septic. So make sure you know all 7 of those names. I'd like you now to go to Schoology, go to the key, and get the rest of the answers for this. Then what I want you to do is I want you to go to the homework, and I would like you to do these 3 problems down here. Now, on your homework, if you picked it up in class, yours says 11, or I think it says 11, 12, and 13. If you printed this at home, then you should have the updated version of 8, 9, and 10. But I want you to do these 3 problems. All right, now I'm going to pause. Now, when I come back, it's going to feel like I never paused it because my pause button on my iPad doesn't really allow me to add any time to it. It just stops and starts. So anyway, pause and do some work. Okay, so let's go back to here. Let's just make sure if you have any questions on leading coefficients, end behavior, turns, degree, or zeros, that you make sure to come ask me next time I see you. Okay, so let's go to the next part of our notes, and what we're going to do is we're going to, I'm going to now apply those rules to an equation instead of to a graph. But all the information is still the same. So first off, let's look at number 1. It says put each polynomial in standard, which is descending form if needed. Okay, so this one is a binomial. I have an x, or excuse me, an a to the first and then an 8, so that is in standard form. I've got a 1 in front of it, and there's a 1 exponent. So state the degree. So the degree is 1. And what I'd like you to do is change this right here. Instead of state the degree and the leading coefficient, this should say state the degree and the sign of the leading coefficient. So the sign on the 1 is positive. Okay, so not only do I have a 1 and it's positive, but remember 1 is an odd number. So how many possible zeros am I going to have? I have a degree 1, so I have 1 possible solution. How many terns? I'm going to take the degree and subtract 1, so 0 terns, because this will be a straight line. And what is the end behavior? So a positive odd will have down on the left, up on the right. Okay, let's go to number 2. Number 2, first off, is this in descending order? I got a 5, then a 3, then a constant. So, yep, that's descending order. Okay, the degree is that 5. The sign of the leading coefficient is negative. So this is odd. So this time I have an odd negative. So let's look and see what that does. How many possible zeros? 5, because it matches the degree. How many turns? Degree minus 1, so it's going to turn 4 times. And how many, draw the end behavior? So negative odd is going to go up on the left and down on the right. Okay, number 3, put these in descending form. So descending form is going to be 7y to the 6th minus y to the 5th plus 5y squared minus 3y plus 18. Okay, and this right here is a y. Okay. State the degree. The degree is this 6. So that is even, and it is positive. Letter B, how many possible zeros? Possible zeros matches the degree, 6. How many turns? 6 minus 1, so 5 turns. And use the arrows to draw in behavior. So even positive is going to go up and up. Okay, let's go ahead and get started with our next section. We are actually going to skip the bottom 3 problems because those are really just like the 6 that we did over here. So there's no reason to do those 3. So we're going to focus for the rest of the notes on this part. And what we're doing here is we're getting ready for a future lesson on finding coordinates that a graph goes through so we can graph it by hand. So let's go ahead and practice that. So as a reminder, don't write this in your notes, but in the past we've had problems like f of x is equal to, say, 3x squared plus 2x minus 5. And then I would say something like, what is f of 3? And we're basically saying, what is the value of the function? What is the value of the function when I replace 3 into the x position? So what we did was we said that would be 3 times 3 squared plus 2 times 3 minus 5. And then we would solve this. So that would be 27 plus 6 minus 5. And so that was 28. So f of 3 was 28. So in this case, this graph would go through the point 3, 28. So let's take that in. Let's do one of these new problems. So I have p to the x. I've got this equation right here is negative 2x cubed plus 5x plus 3. So for p to the negative 1, we're going to plug in negative 1 where the x is. Okay, so now that's going to be p to the negative 1 is equal to negative 2 times. Now, negative 1 cubed is negative 1 times negative 1 times negative 1, so that's negative 1. And 5 times negative 1, well, that is negative 5, and then plus 3. And then negative 2 times negative 1, that's positive 2. And positive 2 minus 5 plus 3, so p to the negative 1 is 0. So this equation right here would go through the point negative 1, 0. Okay, so that's where we're headed in the next set of notes or so. But for future notes, we're going to want to be able to find a function's value by plugging in more variables and not necessarily a number. So we're going to practice that here today. So p to the 4z is no different than p to the negative 1, except we're going to substitute x with 4z. And you'll see later why we want to do this. So nothing big happens here. Okay, well, we got to cube it, sorry. So we've got negative 2 times. Now 4z cubed means 4z times 4z times 4z. So that is 64z cubed. And 5 times 4z is 20z plus 3. So our final answer then is going to be negative 128z cubed plus 20z plus 3. All right, and then lastly, to get ready for pre-cal and college algebra, we need to be able to plug in a binomial in for x. So notice I gave myself a lot of space, and also if you'll notice when you get to these problems on the homework, I said show work on back. So I even put a big black box there. Hopefully you won't, because I do not want you to try to jam all your work in there. Now, before I forget, if you're watching this video, I reduced the homework assignment just a bit. And so what I did was for number 5 and number 6, we're only going to find p to the negative 2 and p to the 1/4. So for both of these, only do those two. And then for number 7, you're only going to do p to the negative m plus 4. So I took off the negative m plus 4 for number 5. I took off the negative m plus 4 for number 6. And I took off the negative 2 and the 1/4 for number 7. So reduced your assignment by 4 problems there, and then only making us do this longer problem one time instead of 3. Okay, so let's go back and finish this up, our last problem. So p to the m plus 1 is negative 2 times m plus 1 cubed plus 5 times m plus 1 plus 3. All right, now, what does that mean? Well, let's go ahead and write out, we're going to get rid of the 3 by just writing m plus 1 multiplied times itself 3 times. And then we're going to go ahead and distribute this 5, so that's 5m plus 5, and then plus 3. So now what we need to be able to do is we need to FOIL m plus 1 times m plus 1. When we get that answer, we're then going to FOIL again times m plus 1. And then we're going to distribute the negative 2. And then finally, we're going to combine like terms. So let's go get started. So negative 2, what we're going to do, oops, let me get a different color here. So let's grab the blue. So this is going to be negative 2. So this is going to FOIL. I'm going to go m times m is m squared. M times 1 is m. And 1 times m is m. And 1 times 1 is 1. Now that's the first two. I still got my m plus 1 over here. And then on the outside, I'm going to go 5m plus 8. All right, now I'm going to distribute or FOIL each of these m squared and m and 1 onto m plus 1. Okay, so but before I do that, I'm going to save myself one step at least. I'm going to combine on the inside and write m squared plus 2m plus 1 times m plus 1 plus 5m plus 8. Okay, so let's go ahead and FOIL again. Okay, this time I got three things to FOIL. So I'm going to go m squared times m. That's m cubed. And then m squared times 1, that's m squared. And then I'm going to go 2m times m. That's 2m squared. And then I'm going to go 2m times 1, and that's 2m. And then I'm going to go 1 times m, and that's m. And then I'm going to go 1 times 1, and that's 1. Plus 5m plus 8. Okay, so now I'm going to combine like terms. So I've got 1m cubed, so that's m cubed. I've got 2m squareds, so that is m squared plus 2m squared is 3m squared. And then I've got 2m's, 2m plus m, so that's going to be 3m plus 1. Okay, so I've done my multiplying. I've multiplied m plus 1 times m plus 1 times m plus 1. Now I need to distribute this negative 2. So negative 2 times this, and times that, and times that, and times that. So I'm going to get negative 2m cubed minus 6m squared minus 6m minus 2. Then finally, I'm going to finally get to combine it with my 5m plus 8. Last thing I have, my answer then, p to the m plus 1 is negative 2m cubed minus 6m squared minus m plus 6. Okay, so that's our notes for today. So as a recap, we need to be able to look at a graph and decide what is the sign of the leading coefficient. We need to be able to decide how many times it's turning, what its degree is, how many zeros it actually has, and how many zeros it could possibly have. Then we also need to know the names of the 7 types of graphs you're responsible for. Linear has a degree of 1, quadratic has a degree of 2, cubic has a degree of 3, quartic has a degree of 4, quintic has a degree of 5, sextic has a degree of 6, septic has a degree of 7. And then you are responsible to do that, all that same information, but be given an equation instead of the graph. And then lastly, you need to be able to substitute a value in for x in any function and give a new function or give a coordinate. If you have any questions about this, see me in Mega Lunch, and I hope you have a good day and you get back to school and you start feeling better if that's what's keeping you at home. Have a good day.